So today we will continue by discussing the two methods that can be used to analyze the problem involving trusses. Okay, so the first method here is method by joint. The second method later on is method by bisection. Okay, so for the method by joint, we have here several simple steps. Okay, for our guideline, the first one is to draw overall free body diagram and solve first. This first method actually apply to both. This first step is actually applied to both method. Even if you want to solve using either method by joint or method by section, the first step must be done. Doesn't matter which method you want to use, but the first step must be done. Okay, so draw overall free body diagram and solve, meaning that if we have one component like this one, okay, we have several parts that contribute to that process. We want to find, at least using overall free body diagram, we want to find the unknown or the force acting on the end of each component. Okay, at the boundary of each component, you want to know the reaction. At least for this example, we will look at later on. Okay, so we want to know the force acting on the boundary or reaction at component that hold the trusses together, so that we can use this information to solve, to be put in the smaller component later on in the trusses. Okay, so the first step must be done for both methods. Method draw free body and solve. Here I put 3: sigma fx, sigma fy, sigma moment, because we are in the rigid body, so we can use the moment. Sigma fx equal to 0, y equal to 0, and moment at any point must be equal to 0 for equilibrium. Okay, and the second step is to choose point for analysis. Okay, what is said by this one is, later on you know that the question will ask you at any of this part. Okay, you have to determine the forces acting on this component. Okay, and normally they will ask you to determine either it is in tension or in compression. As long as we know that the component, all the single component is considered as two force member. So if, for example, the simple one, if we have this type of component, the simplest, okay, let me see this one. Be this one. Okay, so be this component. Let's say we have pin here and a roller here. Okay, if we want to find the force in these three components, let's say this is A, B and C. Okay, if you want to know the force in each individual component, which is this is the first one, this is the second, and this is the third one, we have these three. So this is AC, CB and AB. Okay, we know that it is a two force member, so either in tension or in compression. If I draw it in tension, so it will be this way, this way, and this way. And there's one more thing here, is we consider the joint itself. Here is the joint, so the joint must have same forces by this one. So the joint itself, this is the joint point A. Okay, point A must have same force magnitude but opposite direction. So we have, this is to cater this one, this part to cater this one. So, and here the joint here, we have one more here and the other one here, and one here and one to the other part. And here, of course, because of the external, we have to put another force, reaction force here, and reaction force at D. So, meaning to say here, if we want to find the force at this component, if we know the force acting on this point, we actually know what is happened here and what is happened here. Okay, it is same. Okay, so the first method here is method by joint, by to know this one actually. Method by section to analysis the component itself. Now we analyze the joint, and if we know the joint, we know the other part, because it must be same forces, just opposite direction. Okay, so automatically we know. So that's why we have to choose point of analysis. Okay, so if the question asks you to calculate, for example, the force in this one, this three, so you can use this point F, that include all these three part. So it's up to you to choose which point you want to analysis, depend on the question. And I put some point here, minimum 1 unknown, maximum 2 unknown. Okay, so each point there will be several points. You analyze and you put the thing that you know and the thing that you don't know, and you only can solve maximum 1 known and 2 unknown, because we only have 2 equations, sigma fx and sigma fy. If you don't have any known, you cannot solve. Even though we have 2 unknown, both is unknown, we don't have any known, so it cannot be solved also. It must at least have one component that is known, that we can create the equation and solve the simultaneous equation from here. So maximum we can have 2 unknown, but we must have 1 unknown, 1 known at least to be solved. So we have to find any component. Sometimes the question can be long because the known part come from here, but the one that is asked from the question is here. So you have to transfer information from here, calculate this point, and transfer the information towards the one that is asked in the question. So depend on the question. It can be complex, it can be very easy, or it's not that complex. It just take time because you have to repeat again the process. Okay, so choose wisely this one. And here we have choose simple point, meaning that if you come up to same point that have 1 unknown, 1 known and 2 unknown, there are several points, you should choose component that is simple, meaning that it is all in x and y direction. Okay, for example, if I have here this component compared to this component, I will choose this one first because all is in x and y. Here I have to resolve into x and y again, so it come at the end to here. We can have 2 forces here, 1, and then we have 3 here. So here only 2 already in x and y. So that's what I mean. Choose the simple point. The aim here is you can use this one. You can have the answer later on, but it will drag you some time. So we want to solve the problem at the shortest time possible. So our strategy is to choose the simplest point that we have. Okay, and then lastly, of course, we solve using these 2 equations, sigma fx and also sigma fy equal to 0. Because it is point, we can no longer use sigma moment. It is just a point. Okay, but for overall free body diagram, you can still use sigma moment. Okay, because it is a rigid body for overall free body diagram. So let's see this question. Okay, so I will use this same example, which is exercise 12.1, page 225, to do the analysis. The first one using method by joint, and the second one using method by section. I will use the same example to show you that we can solve using same example. We can use using both method for same question, and you can find out which one is easier to another. Okay, sometime in the question we will ask you to use both method and prove that the both method give you same answer, or sometimes we will not tell you anything. You can choose which of the method is suitable, depend on the type of question, where the unknown is, and where the component that you know is. Okay, so depend on the question also. Okay, but in other words, that you have to learn both method to be used later on. Okay, so the question is this one, exercise 12.1. Where is it? Okay, this one, 12.1. I hope it is clear. Okay, so exercise 12.1. So we have okay. Determine the forces in following truss members and state whether they are in tension or compression. Okay, so that's normally the question. They want you to determine the force in some component, and also you need to determine either it is in tension or in compression. So in your answer, you have to write that right at the end. What is the value? Okay, and in tension or in compression. Okay, so you have to. Okay, so the first one is truss member BC, BG, and SG. BC, BG, and SG. So here let's say do I have this one to make it easier for us? Okay, so let's say we go to the first one, truss BC, BG and SG. BC, so you want to find out here BC, BG and also HG. Here also SG. Okay, so you want to find out the forces in these three components and determine either it is in tension or in compression. Okay, so the first step is to draw overall free body diagram and solve. So overall free body diagram, the component doesn't say anything about the mass, so we ignore totally the mass of the component. And then we go to the external forces. We have 1, 2, 3 external forces. One here, 3 kilonewton. The other one is here, 3 kilonewton, and also here 3 kilonewton. After that, we should go to the reaction force, which is in this case we have one roller here. So roller, one force towards the component 90 degree to the surface. So this is, let's say this is point E, so we call it as E, normal force at E. And then at A we have one pin joint at A, so you should have here AX and AY. Okay, so AX and AY. Okay, so we have draw the overall free body diagram, and then we want to solve to know at least if we solve we can know at least the what is E, what is AX and AY. Okay, that later on can be used to solve the other problem. Okay, if you don't solve this one, later you will be stuck by too much unknown inside the component because you don't know at the beginning. Okay, so we can start by using that I do here. Okay, right hand positive sigma moment. You can start by sigma fx, sigma fy, or sigma moment. Normally we go to sigma moment because it can give you directly the answer. Sigma moment at point. Here you have to know which one you want. If you go to point E, you get the AY. If you go to point A, you got the E. So depend on you. So let's say we have sigma moment at A equal to 0. So this one we ignore for the moment, for the time being. So this one positive, positive, positive. The other one is negative. So 3 times distance 2 plus 3 times distance 2 to 4. So this one I will go really fast because I assume all of you are already familiar how to take the moment. If not, please go back to the previous video on how to calculate the moment, what is the distance, what is the force, and so on. Okay, so 3 times 2 plus 3 times 4, and then plus 3 times 2, 4, and 6. Okay, and this one you put a pin here, pull, it will go counterclockwise, so negative E times 8 equal to 0. Okay, so from this calculation you can have E equal to E, which is I have calculated, you got E equal to 4.25 kilonewton. 4.25 kilonewton this direction. Bear in mind, the normal force must always positive from your calculation. The AX, AY might be negative because it is assumption. But the E, because it is must always towards the component 90 degree to the surface. So it must be always positive. If you got normal force like this one as negative, meaning that either your free body diagram is wrong or your calculation is wrong. So you please check back your free body diagram and your calculation. You should always have E as a positive answer if you draw correctly the free body diagram. Okay, so this is a roller. E must towards the component 90 degree to the surface. And then we can go to sigma F what? Here. Fx equal to 0. We have AX, no force in X direction, so AX equal to 0. We go to Y, sigma Fy equal to 0. Let's say upward is our positive, so we have AY minus 3 minus 3 minus 3. Okay, plus A, which is this is the value of E. You have the AY equal to from here 4.75 kilonewton. Positive meaning that same direction as what is assumed. Okay, so we have the value of E and AX and AY. Okay, so I will put it here so that we can use in our calculation. AY is positive 4.75. E is 4.25. AX, I will put away directly AX because it is equal to 0. Okay, so our AX equal to 0, so only force that have this one. Okay, so we go to the second step. So this is the first step. Draw overall free body diagram and solve for the unknown at the end of the component. Okay, at the end of the component. Okay, we go to the second step. Choose point to analyze. Okay, and we will consider all the forces. At first, we consider all the component is in tension, meaning that all is in tension outward of the component. Later on, if you got the negative value, it is just indicate to you that the magnitude is correct, only it is in opposite direction. If meaning that it is in compression. Okay, so we assume first everything is in tension. Okay, so we want to do the know the force here 1, 2, 3. So the possible point that we can analyze is, maybe you can go to point B. So we have 1, 2 force. If you go to point H here, we have 1, 2. Okay, if you go to point G, we have 1, 2. And if you go to point C here, we have only 1. So maybe in this case, I will consider to analyze the point H, G, and B. Okay, from point B, I got 2. From point G, directly I can put it here. H also you can here. Okay, so we'll see. Either these 3 points suit in our criteria, which is at least 1 known point and 2 maximum unknown forces. So we go one by one. Point B. Point B, we have, I consider everything in tension, so outward of the component. FBC, FBG, FBH. Okay, doing like that, and we have one more here, FAB. Doing like that, meaning that we want to say that the component, let's say we have here the component, this one, BG is in this direction, in tension. It is opposite from this one, it is in tension. Okay, so from here you can see that we have 0 known and 4 unknown. For sure, you cannot start by this point. You go to the second point, point H. FBH, FHG, FAH. Okay, FAH. So what do you have here? 0 known, 3 unknown. You cannot go to that point also. And point G, go to point G. We have a lot more. FGD, FGF, FGC, FGB, FGH. Okay, forgot to put one more here, which is at point H here. This is point B, this is point H. So at H we should have downward force, which is 3 kilo. So we have 1 known and 3 unknown. So here also we should have 3 kilo. So from here you have 1 known and also 5 unknown. Okay, so that's why we cannot start by any of these 2 points. If you go to the other point, it also will create you same thing, which is 1, 2, 3, 4 unknown. Here we have 1, 2, 3 unknown. Here we have 1, 2, 3 unknown. If 1 unknown. The only thing that you can go is either start by here. We have 1, 2 unknown, but one known here, or this one, 1, 2 unknown with one known. Normally we will choose the simplest one. If you start by this one, you have to transfer, it's long. So you have to start by the part which is shorter for you to transfer. Okay, so we go to point A. So normally I will go to point A. Point A, so you have here FAB, FAH, and you have one which is AY equal to 4.75, one known, two unknown. Okay, so we can start by here. Okay, so we have to start by this one, which is we have to start by point A. And then if you start by point A, you can know these two, and then you can transfer here, making this two known and two unknown. You can solve. Also, you go to this one, you're making it a one known, three unknown, but you already solved this one. You can put it here, two known, two unknown. So my step will be, this will be the first point that I analyze, this will be my second point, and this will be my third point to cover all these three needed. I don't have to go to this one. Okay, so you already covered all the points that I need. Okay, so we have 3 points to analyze here. So you go to the first one. Based on the dimension given, this is 3, this is 2, so you can calculate the angle in between, so which is 56 point. This is here 56 point, what do I have, 31 degree. Do I have blue? Okay, blue is here. Okay, so now I have this point to analyze. I start by this one. Okay, so what we can do here is we have we cannot use the moment, we can use the sigma fx, sigma fy. If I use sigma fy, I can directly have the FAB. If I use sigma fx, I have two unknown here, so I cannot solve. So we go to sigma fy first. So each time before you start, you have to at least think a little bit, one step further. If I use this one, can I solve? If not, I have to choose the other one. So you don't lose a lot of time. Okay, so sigma fy equal to 0. We start at point A, so FAB. You resolve into XAY. I will not show directly here because you already done it 100 times. Okay, 100, more than 100 times. So you are already really familiar with that. So resolve 1x and 1y and 1x. So FBX, FB, which is sine 56.31 degree, plus this is upward, this is also upward, 4.75 equal to 0. You have FAB. Go ahead, calculate. Okay, so I've already calculated that one, so that we can have easier, faster result here. Equal to minus 5.71. Okay, so minus 5.71, which means that actually here FAB equal to 5.71. It is in compression, because we consider everything is in tension. If you got negative, it is in compression. Okay, so go. And then we go to the second point, which is, no, the second point is still the same point, sigma fx, positive, fx equal to 0, so you have FAH plus FAB, sine 56.31. Okay, so FAB in our calculation, based on this figure, our value is negative. Negative 5.71, so you get FAH equal to FAH in this case 3.167, 7 kilonewton. It is positive, meaning that this one is in tension. Okay, But in this case, you don't really have to answer here in tension, in compression, because it is not in the question. But I write here to make you understand what is meant by positive and negative value here. Okay, so we have two of this, which is FAH and also FAB. It is not the one that asked, but it can be used to other point because we want to know here. Okay, so the second step. Here, we will try to transfer to point H for the second point. You have two choice. Either you maintain this figure and then you put the value from your calculation, meaning that FAB here, not that you don't have FAB, FAH. FAH here is positive and here FAB is negative value. Either you maintain this figure, you put a negative value, or you change the figure. We know that now there is compression, so this figure should go inward, and you put the positive value. It depends on you. It will give the same result. If I want to maintain, because when we use the pen in your exam, you cannot just simply erase. You have to redraw back. So maybe take your time. So that's why I'm thinking of you just put directly the value of negative, same figure. Or in this case, I can go to this way, up this direction, and it is positive 5.71. I change the direction in the figure, but I positive because now I already know what is the value. So depend on you what is the easier. Okay, if you want to go this way or if you want to go same figure, this direction, but you put negative because this is the original figure. From the calculation, it comes to negative. So let's say I want to change this one because it's easier for me to change. I want to put everything in positive. Okay, so 5.71. Here is already same. FAH 56.31. 31.67. So I have FAB 5.71 and 3. Why is it 36? 3.167. 3.167. Okay, so this one I can eliminate. I can erase this one. We can concentrate on the other part. Okay, so now this one become 1 unknown and this one 3, 2 unknown and 2. So of course we have to go to the point H. The second point is point H. Okay, so you have 2, 1, 2, 3. So you have 2 FGH. Where's my FGH? Also no. This is from the previous figure down here. So this 3. Okay, so I know directly what is here, what is here. Okay, so from here you can have positive sigma fx equal to 0. So you have FSG minus 3.167. Okay, minus is because of this direction. The value is positive. Okay, from our calculation. So minus because of this figure. FSG minus this one equal to 0. So you have FSG equal to 3.167. Even though, okay, it is asked in the question. So FSG equal to 3.167. And it is positive, so it is in tension. So this is your answer. You must write this way, meaning that the part that is needed and in bracket the condition in tension or in compression. This must be in your answer. If you just write this one without, or if you got negative, you just write positive, or you just write negative there, because you said that negative is in compression, but you didn't state it here, you will lose mark. If the final answer is 1 mark, so this is half, this is half. Because it is asked in the question, stated the force inside and the condition, tension or compression. So you must write this one, in tension or in compression. Don't just assume it is positive in tension compression. No, you have to state it. You have to state that one. Okay, so we know this one, FSG. Okay, so now we know this one. Settle. We can calculate this one. FBH positive sigma Fy equal to 0. Positive upward, FBH minus 3 equal to 0. So FBH equal to 3. FBH equal to 3. It is not in the question, so you can leave it like that one, or you can also put it in tension. Okay. What I highlight here is the one asked in the question. So you highlight this one. But I want this to be put here. If not, I cannot solve this problem. Okay. So now we have finished for that one. We can go to the last point, which is point number 3. So from here, I can transfer here, which is equal to 3 kilonewton. So I can erase the other part. Okay, so the first question that is asked, we know from here, FSG equal to 3.167 in. At least you do it like this. If you don't want to just write the full tension, you just put T. Compression, you put C. So at least. Okay, if you really think that you don't have time to write, just put like that one. Okay, so now I have solved here. Put it here, so we go to the last part. Okay, which is now become 2 known and 2 unknown. Okay, so 2 known and 2 unknown, you can solve this one. But of course, you have to calculate what is the angle in between all of this. Okay, the dimension is given, so you can calculate the angle. So I've already calculated this one. So this from here, so you got this one is 56.31. So here you have 2, 36.87, and the other one is 56.31. Okay, because you want to resolve everything in terms of x and y. Here, positive, 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 negative. This one already negative. This one is upward. Okay, so you can solve if you use what? The both unknown is in have x and y direction. So either you go to x direction, you have 1 unknown. If you 2 unknown, if you go to y direction first, you have 2 unknowns. So any direction you choose here, you still have to use simultaneous equation to be solved. Okay, so doesn't matter sigma fx or sigma fy. Let's say okay, we solve using sigma fx equal to 0. So I have FBC cos 36.87 plus FBG cos 56.31. This one is 0 plus 5.71. This is also cos 56.31 equal to 0. Okay, so you know you have 1 unknown here, 1 unknown here. Good, so let it be this as equation number 1. Okay, and then we go to the y direction. Sigma Fy equal to 0 minus 3 from here. Okay, minus 3 plus this here plus 5.71 sine 56.31, and then plus FBC sine 36.87 minus this one minus FBG sine 56.31. One positive, negative, so negative, positive, positive, and negative equal to 0. So this will be your equation number 2. Okay, so once you solve 1 and 2, solve these two simultaneous equation, what you will have is FBG. Okay, so I put it here. FBG equal to negative 0.5038 kilonewton. This is from your calculation, so your understanding. Okay, so the what is mean by this negative is FPG equal to 0.5038 kilonewton. It is in compression. This is your answer. Okay, so this is your answer, and then you put back this original value negative inside. If you solve from 2, you put in 1, then you put this one back in 2 in second equation. You can have we have FBC. Okay, make sure you put the original one from the calculation. So negative in your here, you can have FBC negative 3.6032 kilonewton, which means that FBC is equal to 3.602 kilonewton, also in compression. Okay, so your final answer must have this FSG value, kilonewton tension or compression, FBG value condition, which is in compression, FBC value compression. You must write that one. If not, you will lose someone. Okay, so that's all. For the first method, again, any of these two methods, both of the method, you have to start by drawing the overall free body diagram and solve for the end of the component. Okay, at the boundary conditions, so that you know the forces, the reaction that it can be help you to other part, and then you choose point by point that can give you the answer for the other part. For the part that is asked to you in the question, so at least you want to find the part which is 1 known and 2 unknown maximum, because you only have sigma fx, sigma fy, and then solve that one. Once you know, you put back in the other point, then you can solve to the other point. Okay, at the end you get the answer. Make sure you write the answer accordingly. The question asks you either in tension or compression, so you have to write it directly, tension or compression. If you don't want to write tension in full name, you just put T and compression as C. Okay, so that's all. We will go to this second method, which is method by section using the same example later on. Okay.